Hi everyone, I am Paul Bard and I'm going to talk to you about adversarial soft advantage fitting, or how we can do imitation learning without having to train a policy. Imitation learning is when an agent learns to imitate an expert from demonstrations. Demonstrations are recordings or trajectories of the expert performing. Similarly, the learning agent produces trajectories by interacting with its environment. The challenge is now to match the generated trajectories with the demonstrations. Adversarial imitation learning uses the generative adversarial networks, or GAN paradigm, to train a discriminator that can tell apart expert trajectories from generated ones. This discriminator then provides a good reward that we can use to train the agent with reinforcement learning so that it behaves more like the expert. Now, this involves two steps. We have the discriminator training and the policy optimization step, which is done by reinforcement learning. This last step is known to be brittle and hard to tune in practice. In this work, we propose to remove the reinforcement learning step. Adversarial soft advantage fitting enables you to directly derive a policy that resembles the experts from the discriminator training. By removing the RL procedure, ASAF is able to increase performance and robustness to tuning while drastically reducing the algorithmic complexity. Instead of directly parameterizing the discriminator, ASAF uses a structured discriminator which explicitly depends on a learned policy P tilde. This is the same structure as the optimal discriminator from the GAN framework, and therefore, at optimality, the probability of a trajectory under the learned policy matches the probability under the expert policy. Now, it only remains to link this probability to the policy. Writing down the probability of a trajectory under a given policy in a given environment, we can express the discriminator in terms of the policy, and we see that the environment terms cancel out. Once simplified, we see that the discriminator only depends on the policies. Putting all this together, it follows that at optimality, the discriminator retrieves a policy which induces the same trajectory distribution as the expert. In other words, even when optimizing only the discriminator, we are still able to get a policy that imitates the expert. We test different versions of our method on multiple environments. We show here that ASAF outperforms the baselines on Pomerman, an environment with discrete actions. In the paper, we also propose results on Mujoko, where the agent uses continuous actions. Thank you very much for your time, and please check out the Spotlight video and our paper for more details and results.